discuss properties of kites. We'll get into a few properties here before we discuss some examples. In a kite, there are two sets of adjacent sides that are congruent. These sides, DC, is congruent to BC, and AD is congruent to AB. One set of opposite angles are congruent. So angle B and angle D are equal in a kite. Two other properties involve the diagonals. The diagonals cross at a 90-degree angle. Notice that it creates four 90-degree, four right triangles. The segment that connects those congruent angles from A to C, that segment gets cut in half, so the distance from AE is equal to the distance from CE. Let's look at example 1 here. Find the value of x, then find the measure of angles A and B. Well, we may not find x per se right away in order here. I think I might find a way to find angle A because I know that one of my properties says that one set of opposite angles are congruent. So if angle C is 101 degrees, the angle across from it in a kite is equal. So that means angle A is also 101 degrees. The next thing I need to remember is the polygon angle sum theorem. This is a four-sided figure, so we can figure out what all the angles are going to add up to by plugging in a 4 for n times 180, we get 360. So if we add all of the angles, we add 17x plus 10 plus 101 plus 101 plus this 29, it's going to equal 360. Let's combine like terms and solve. So we combine those terms, it gets us 241. Remember, we got to get rid of the number, so we subtract 241 on both sides, leaving us with 17x equals 119. Solve for x by dividing by 17 on both sides, and we get x equals 7. To find angle B, because we already found angle A was 101, to find angle B, we're going to take this value and plug it back in to our expression for angle B, replacing the x with a 7. Calculate that out. Angle B is equal to 129 degrees. Example 2. Now we're trying to figure out the angle measures. But first, question 1 says, given that AE equals 10, can you find CE? If you recall one of our properties, the diagonal that connects the two congruent angles gets cut in half. So that means if AE is 10, CE is also going to be 10. Question 2, can you find the measure of each angle? So all of these numbers just represent an angle measure. If you recall, diagonals are perpendicular. They cross at 90 degrees. So if you remember the diagram, all three angles here are 90 degrees. Now to go from here, we have 90, a right triangle. And I know we have 75, we've got 90, we've got this angle 4, that's our unknown. But if I add those three angles, it's going to give me 180 degrees. That property of our triangle sum theorem still is at play. So we can solve this. We can add the 75 and 90, and we'll take it away from 180 to figure that angle 4 equals 25. Now, recall that we have one set of opposite angles are congruent. And I notice a mistake here. That is angle A is congruent to angle C. This angle is congruent. So, if this angle is 28 degrees, angle 5, that's in the same placement, so angle 5 is going to have to be 28. There's a 75. That means angle A is going to have to be 75 degrees. And now we have, remember, this is also 90 degrees in here. So we have a 90-degree angle, 75. It's the same triangle. So angle 9 is going to have to be 25 degrees. Now we're just going to solve this right triangle up here. We've got a 90, 28 degrees plus angle 6. That's going to get us 180. Combine our 28 and 90. Take it away from 180. Angle 6 is 62 degrees. This triangle is the exact same thing, so angle 7 would also have to be 62. Last example. Find the measures of BC, CE, AD, and CD. So we're finding some side lengths. If you recall, BC is going to equal 23 because these two sides are equal. If AB is 23, BC equals 23. Again, this property says this segment gets cut in half. So if AE equals 17, CE is going to equal 17. The last thing we know is that AD, this segment, equals DC. So if we have expressions with x, that means we need to come up with an equation. Well, if they're equal to each other, I can replace AD with 21x minus 7 equals CD with 16x plus 13. Now I can solve for x. Get the x's together on one side, leaving us with 5x minus 7 equals 13. Add 7 to both sides. So we get left with 5x equals 20. Divide by 5. On both sides, x is going to equal 4. So to come up with the side lengths, we're going to take that value and plug it in to our segment for AD. Instead of x, I'm going to replace it with the 4. So AD equals 77. We know DC is going to be the same thing, but I like to double check to make sure I didn't do any algebra wrong and solve for the wrong value. So if we plug in 4 for x, we still get 77, which tells us that, without having to ask Mr. Ryan, I know that this is the correct value for x because these two segments are equal.